Satya Prasad. I'm working for Customized Energy Solutions as a manager of consulting operations. And today I'm representing ISA, India Energy Storage Alliance as well. ISA is our industry platform, which is intended for various battery energy industry stakeholders to interact, to exchange information, to participate in uh, policy activities, and also to get some manufacturing or various other consulting exercises as well. My objective today is to briefly explain the emerging trends that have been observed in the BESS industry for the past 6 months to 1 year. Without any delay, I'll start my presentation with a brief slide about how BESS in general are integrated by various OEMs. So this slide shows how the containers, the BESS containers or DC blocks are generally manufactured. Everything starts from a cell, a small subunit. It's like a building block of any energy storage system, which is around 5 to 6 kg depending upon the technology used. Maybe 100 to 120 such cells are packed and placed within a strong steel enclosures, and these are called battery packs or sometimes battery modules as well. I hope Yashodhanji is going to detailedly discuss about the packs in his presentation. So apart from the cells, the packs, they tend to have sensors, BMS, that is battery management system as well. BMS monitors each and every cell present in the pack on a continuous basis to ensure safe operation. Maybe 20 to 25 such packs, they are loaded onto a sturdy steel structure called racks. They are like your traditional shelves, which provide a space for safe placement of these packs. Each pack might be weighing around 500 to 600 kg, and definitely you require a sturdy structure to support their placement. Apart from housing the modules, these racks, they tend to have various DC cabling, monitoring systems, and etc. etc. So these racks are finally placed in a container, which are very much similar to the shipping containers you see in your daily lives. They are called storage containers. In the industry parlance, they are also called DC blocks. Apart from these cells, the racks you have seen, each DC block, they have various other subsystems like fire detection or suppression system, HVAC for cooling the entire system, because these batteries, they generate tremendous amount of energy or heat, both while charging and also discharging. As such, they definitely require some cooling mechanism. So the storage container houses a cooling mechanism as well. And apart from this one, it houses the HV panels, various assorted equipment like cabling, sensors, etc., etc. All of them are packed together into a single storage container, and these storage containers, with the help of PCS and high voltage transformers, they either draw power from the grid or inject power into the grid. This is how the BESS system generally works. And as it is a culmination or package of various subsystems, generally these are called battery energy storage systems, because it's not a simple battery and it requires various other subsystems to work in a proper way. In the next slide, I have briefly discussed about a market update related to BESS participating in energy exchanges. So SECI, as given in the introduction, SECI is involved in floating a lot of tenders of grid-connected BESS systems in India. As a matter of fact, it has already floated tenders for more than 5 gigawatt hour, I guess, in the first half of this year itself. And recently it had floated one such tender for developing ISTS connected BESS in Nandyala district of Andhra Pradesh. The unique thing about this tender is that the asset constructed under this tender, that is the BESS project, the entire BESS is earmarked for energy exchanges. Now, if you see the traditional tenders or projects that have been identified till date, the entire storage capacity, as shown in the bottommost figure, the entire storage capacity was contracted and offtake by a single discom. There was hardly any chance of merchant operation where the project could participate in the energy exchanges or energy markets. There was only one exception where SECI had floated a tender with some merchant capacity, but it was eventually cancelled due to some legal hassles. Um, so in that regard, this particular project is a unique in that it will act as a beacon for many such storage projects in future. We may see many such projects directly interacting with the consumers on a peer-to-peer basis on these energy exchanges, selling their storage as a service. It is kind of, in essence, requirement of any smart grid. The ability to perform some peer-to-peer transactions without any centralized discoms or utilities, in the transactions. So that is one interesting commercial innovation related update I have to share with the delegates today. And another update again is a market update. It is about government plans to use battery storage in the thermal power plants as well. So till now, when you say battery energy storage system, the image in your mind is obviously RE working in tandem with battery energy storage system to power to supply resilient and reliable power. But for the first time, government is planning to set up BESS system even in the thermal power stations. The reason is simple: because of tremendous RE power that is injected into the grid. The PLF, that is the plant load factor of various thermal power stations around the country, had been dropping, and last year the average PLF was less than 70%. Now, running these thermal power station at lower PLF affects their efficiency. Apart from affecting their efficiency, it also means that valuable time is lost, where these generators could have been generating electricity, but they are standing idle. So usage of BESS in the thermal power stations, it is expected to increase their PLF and also expected to generate more units within a year. And government expects that the cost of electricity generated in such a way may be less than what is observed now. In line with the government's plans, NTPC has already floated a tender, EPC tender, for supplying 4 gigawatt hour of battery storage at many of its thermal power stations in Uttar Pradesh and surrounding areas. And a thermal power station in North Chennai is also about to get its own BESS system working within its arena. So the commercial implication of tagging BESS to thermal power station is yet to be revealed. We have to see how the entire thing pans out in future. Next important and interesting update is Indian government's policy to make it mandatory to include indigenous EMS in all the BESS storage projects that are applying for VGF. Now you may have a question, what is VGF? VGF, which means viability gap funding. It is a central government launched scheme which was launched in somewhere in 2023. The overall objective of this scheme is to improve the commercial feasibility of BESS that are coming in India. Under this scheme, whoever is applying for this fund, they can get a maximum of 30% of the capex as a grant, that is as an incentive to set up the project in anywhere in India. And another question is, what is EMS? EMS, the short form of energy management system. It is a software like the kind of brain of any BESS project. So it decides when, how, and where to charge or discharge your energy storage asset. It can use complicated algorithms to utilize your asset to the maximum extent possible. Now, what might be the resultant of this policy update? There are certain advantages due to this policy update. One is, traditionally, most of the Chinese vendors, they used to supply the entire solution in a packaged version where they used to supply storage containers, they used to supply PCS along with their own EMS. So everything was offered generally as a package. Now, this particular rule of indigenous EMS opens up the market for many indigenous integrators and also EMS suppliers to make some transactions. And apart from that one, EMS, by the very nature of this, it's working, generates billions of data points every year from every operating asset. So billions of data point means terabytes of data generated by these storage assets. If you use any foreign player, a copy of the terabyte of data is generally sent to their data centers, which might be anywhere around the globe. But using an indigenous EMS, make sure that all the data, whatever that is generated by these, power stations or power projects, they can lie well within the national boundaries. And many of the delegates, they might be aware of the importance of data and how sensitive it has become to store the data well within the national boundaries. So in that regard, this policy goes in a positive step. But other operational complications associated with using indigenous EMS, it has to pan out. As a matter of fact, ISI is conducting a chat show about EMS, indigenous EMS suppliers. It might be starting in some time, but we are expecting to learn more about the operational hassles faced by these indigenous suppliers. And here is my final update. It is a slightly technical update. If you see in the industry, the cells are becoming bigger, and energy storage containers, they are packing more and more energy. Just to give you an example, I have included two situations. One is a smaller cell, which is around 314 ampere cell. Another is a larger version, which has 1175 ampere hour of capacity. So if first cells are used to manufacture a storage container, you can pack around 5 megawatt hour of energy storage capacity within 20 feet container. And if you use the second cells, you can pack 6.25 megawatt hour of energy storage capacity well within the same 20 feet container. So what it means to manufacture or be able to manufacture larger capacity containers? One is reduced cost of the container with respect to kilowatt hour. In the first slide, we have discussed that apart from the cells, there are many other subsystems which we call balance of system subsystems. Though the energy storage capacity is increasing, the increased capacity is going to use more or less the same BOS system, which means the cost of BOS will be diluted and becomes less when seen from kilowatt hour perspective. This is how it can reduce your cost of container, that is the price of each container. And apart from that one, the number of containers required for project developers also falls down. If we take a hypothetical scenario where you need to install 75 megawatt hour capacity of project, using the first solution, you may require around 15 containers. But if you go for the second option, you may require only 12 containers. So reduced containers means reduced land for the project and also reduced land development cost for the developers. Apart from that one, there may be many other reductions as well, like reduced connection cabling, etc., etc. So the overall idea is that increased energy capacity of each container, it is expected to reduce the cost for the the project developers. And eventually, the reduced cost of energy storage capacity may be, finding or maybe passed down to the consumers as well. So that is positive in that regard. But there are certain complications as well. Like the first solution is around 40 tons, whereas the second one is around 50 tons. So handling heavier containers is a little tricky and may require specialized cranes or handling equipment. And as far as we know, integrators are working very closely with the project developers to find solution and to handle the equipment in a seamless way. So there comes the end of my presentation. As I have explained in the introduction, CES offers various advisory services for cell and pack manufacturing, advisory services for companies intending to participate in the grid level storage tenders or bids. And we also help C&I customers to optimize your power consumption and reduce your overall power costs as well. If you are interested to know more about our services or to know more about BESS in general, feel free to drop a mail at the email address included in the presentation. Having said that, thank you very much, Vivek ji, and thank you very much, Sohel ji, for this opportunity.